Good day, grade 12 learners. Welcome to today's Physical Sciences Paper 2 Prelim Revision lesson. My name is Tandiwe. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Now, as you know that tomorrow on the 28th of September, we will be sitting for our chemistry paper, which is our paper 2 in physical sciences. Therefore, that is why this lesson was brought to you so that you can get ready for tomorrow. But before we can start, I just like to say to you, as we are going to do this lesson, make sure that whatever that you feel you didn't understand, I know your teachers are with you. Some of you have people that are assisting you. Make sure that you ask them anything that you don't understand about today's lesson so that they assist you for tomorrow's paper. What is it that you need to have as we are going to start? I think we need to be ready before we start this lesson. Now, you are also welcomed to communicate with us through our WhatsApp line, which is 064 748 8913. I will definitely try to make sure that after each and every short break, I look at your questions so that we can try and assist you in answering tomorrow's paper. Therefore, what is it that you will need for this session, at least so that you can also participate actively? You will need a book to write, of course, so that whatever that you want to note down, you have a book that you're going to use to write on. You also need a periodic table of elements. I always encourage you that whenever we are going to do a chemistry lesson, always make sure that your periodic table is next to you. And you also need the standard reduction potential table. So both the periodic table and the standard reduction potential table can be, you can get them from your exam guideline. So therefore, you can also have your exam guideline 2021 that will also assist you in order of reference. You will also need a calculator because there will be some few calculations that you will do. You know that in chemistry we don't do so many calculations, but definitely there are those calculations that you normally conduct in chemistry and you will need a calculator. And you know, I always encourage you to use the same calculator that you are used to so that you don't find that tomorrow as you are trying to press some of the buttons or you are trying to operate it, you are unable to operate it. So these are the things that you can have as we are going to start with our today's lesson. Now, let's start with the structure of the paper. What is it that you can expect in chemistry paper 2? You must know that it will have question 1 up to question 9. Question 1, it will be our multiple choice questions. And I think by now you know that for multiple choice, we are having how many marks? We are having 20 marks. So it means multiple choice will be having 20 marks and the rest of the paper will be having 130 marks because the total of the paper is 150 marks. And we already know that for us to be able to pass this paper, how many marks in terms of the percentages or how many marks must we get so that we can get a correct percentage that will make us to pass? What is our question 2? Our question 2 will look at the IUPAC naming and homologous series. We'll look at question 3, which is based on physical properties of organic molecules, and question number 4, organic molecules reactions. So if you can check that from question number 2 and number 3, all these, they are about organic molecules. So therefore, it means organic molecules is having a little bit a high percentage in terms of our paper 2, which is our chemistry. Then question 5 is going to look at the rates of reactions. It's going to look at the factors that affect the rates of reactions. And then question number 6 is going to be our chemical equilibrium, which is going to include Le Chatelier's principle. And then we are going to look at question number 7, which is our acids and bases. Question number 8 and 9 is electrochemical cells. And they are divided into question number 8 and question number 9. So question number 8, it will be our galvanic cell, and question number 9 will be our electrolytic cell. So already you know what is it that is expected from you tomorrow. Therefore, it means by now you know which topics you have a lot of strength on them, so that when you start tomorrow, 9 o'clock, starting with writing of your paper, you know which questions are you going to start with, that you know that you have a lot of confidence in, and you know that you can score a lot of marks on. Now, what is it about multiple choice? What is inherent on multiple choice? What you need to know is that multiple choice will have all the topics. All the topics will be examinable on your multiple choice questions. And each question has 2 marks each. Therefore, it is very important that before you make a choice in your multiple choice, you make a choice, an informed choice, and thoroughly deliberating on your choice, because for each and every question, 2 marks is allocated for that. Therefore, you cannot afford to lose 2 marks just for choosing without thinking. Identify which topic does the question belong to in order to collect the facts. I think for you to be able to start answering the multiple choice question, you firstly need to identify where does this specific question come from. As I said, that multiple choice will be asking different questions, will be asking questions of different topics. Therefore, firstly identify in which topic does this specific question belong to. Immediately when you identify that, your mind will be tuned to that topic and you'll start gathering the facts about that topic. So you also need to thoroughly analyze before attempting any choice, before you choose any answer, because you will always be provided 4 or distractors or 4 options. So before you choose any option, you need to thoroughly think about the option that you're going to choose. But that will only happen after you have identified in which topic does that question belong to. Minimize the distractors in order to make the question easy, from 4 maybe to 2. I think you know that as they're going to give you 4 distractors, maybe some of the distractors will be very close to each other in terms of the correct answer, but some will be far. So make sure that you try by all means to minimize your distractors. Maybe leave 2 distractors or 2 options that you can choose from by understanding what is happening in that specific topic. Now, our question 2, as I said, we are going to look at the IUPAC naming and the homologous series. This is the question that contains almost the entire understanding of our organic molecules. Now, you need to know that every question will start with a definition. Even if the definition is there, but you know that every question in physical sciences definitely will have a definition. So therefore, you need to know those definitions. These are some of the definitions that I think we need to remember. Definitions like homologous series. What is a homologous series? I cannot overemphasize the issue of you utilizing the exam guideline to find the definitions. Therefore, if you want to know the definition of each and every term that you are provided, you definitely need to consult your exam guideline that will assist you. You need to define functional group, which is another definition that you must make sure that you know. If we knew the question paper, we would give you any definition that is on the paper immediately. But because we are learning everything, not knowing what will be the part of the exam, therefore it means you need to know everything that you need to know, because your exam actually is not important. The questions on the exam, they are not important. What is important is what you are going to have as you are going to go to the exam room. Therefore, when you know everything, then that paper becomes an easy paper because you are already ready to write the paper. So you need to know what is a homologous series, what is the functional group, and you need to know that we have general formulas, we have structural formulas, or semi-condensed formulas, and molecular formulas. These are the things that we discussed when we were thoroughly discussing organic molecules at the beginning of this year. So those are the things that you must also go back and check whether you still remember what do I mean by a general formula. But to make things easy for you, you know that general formula, we normally know the one of alkanes, alkenes, and alkynes. And we know that what was making them to be different, alkanes was CnH2n plus 2, alkenes was CnH2n, and alkynes was CnH2n minus 2. Just to remind you what is the general formula. And then in terms of the structural formula, I think most of us, we know what we mean by structural formula or semi-condensed structural formula. And then the molecular formula, we know that is the formula that indicates the number of atoms in that specific compound. We also looked at saturated and unsaturated compounds, and we know that as we're looking at the saturated and unsaturated, we know what does saturated mean and unsaturated mean. So those definitions are also provided to you on your exam guideline, whereby they were telling us that saturated compounds are compounds with only single bonds, whereas unsaturated are compounds which having multiple bonds. So those are the ways that you need to remember. Remember, as I'm doing this revision, some of the things that we did before, they cannot be covered, but we are trying by all means to say, mind of the things that we talked about in our previous lesson, so that you know that you are prepared for tomorrow if those things were already forgotten. Then we talked also about isomers. whereby we talked about structural isomers, and we said structural isomers are isomers with same molecular formula but different structural formula. And if you didn't understand what is meant by molecular formula, definitely it won't be easy for you to understand isomers, because what makes the isomers to be isomers is that they must have the same molecular formula at the beginning, but when you draw their structure, which is our structural formula, they must have different structural formula. And our structural isomers are divided into functional isomers, positional isomers, and chain isomers. And those isomers were also explained to you. Just go back and check what makes the functional isomer to be a functional isomer, because we look at the same molecular formula in all of them, but what makes them is their structure in terms of the functional group. In terms of the positional isomer, the positional of the functional group, and also the chain isomer, the chain length. The other one is branched, the other one is unbranched, or the other one is less branched. So you need to make sure that you go back and look at these isomers. Then you need to also know the names of the functional groups. We know that we have those functional groups that have specific names, or that are awarded or are afforded names. Like, for example, we know that alcohols have hydroxyl group as the functional group, carboxylic acids, carboxyl group, ketones, carbonyl group, and aldehydes, formyl group. It is impossible for us to go through everything that you did in organic chemistry, but these are some of the things that you can make them handy for you to understand what is going to happen in our next lesson. Then we also look at naming. I think when we're looking at naming, there were rules that were stipulated of us to follow in order to name the compound correctly. We know that the first thing that we had to do is to identify the functional group, where that a specific compound belong to, or of that homologous series. I think I emphasize the issue of differentiation between functional group and homologous series, because we understand that if you are a homologous series, you are a series of compounds whereby the next member differs from the other member by CH2, which is the definition, or which is another definition that is provided by the exam guideline. Therefore, for every homologous series that we dealt with, we know that they were having different functional groups. Go back and check the 9 functional groups that we looked at. Some of the functional groups were almost the same. That is why those compounds ended up forming the isomers. So you need to check the functional groups of different homologous series, so that you can see what makes them to be different, and if there's something that is similar, what makes them to be similar. Therefore, you need to make sure that you go back and look at that. And then the suffix, like for example, for alkanes we have ANE, alkanes ENE, alkanes YNE. This suffix will also assist us: alcohol all, aldehydes al, ketones on or one, and then oic acid for carboxylic acid, and OH, ethanoate, OH for the esters. So you need to also look at the suffix, because they will assist you to be able to identify in which homologous series, in which functional group does that specific compound has. So this is just to remind you what do we mean by a suffix, the last word in a name of a compound that will identify where does that compound belong to. And then you know that the next thing that you need to do after identifying the homologous series, after knowing where does the specific compound belong, you need to look at the longest chain. Remember, the longest chain has nothing to do with numbering, but the longest chain is saying how many carbons are there that are following each other in a specific pattern in a chain. Therefore, you need to identify the longest chain. And then after identifying the longest chain, you can now start numbering your carbons according to the functional group, or according to the substituents which is closer to the gate, or which is closer to the edge. We normally say where it's closer to the end, and we know that when you refer to the end in our scientific way, the end, it can be the beginning, or the end, it can be the end, or the beginning can be the end. It doesn't matter, but you look at the carbon that is at the edge in terms of numbering your carbons, and where is the substituent or the functional group. You know that after we have determined that, you know that we need now to write the name of that compound. And writing the name, we know that we are using hyphens, we are using commas. So it is very important also to remember, even now, when is the hyphen going to be allocated, and when is the comma going to be allocated. We use a hyphen between a number and an alphabet. And I think we know what are numbers from 1 to 9. We use alphabets, which is A up to Z. So if we are separating a number and an alphabet, we use a hyphen. However, if there are two numbers that are following each other, we know that we use a comma like this. Or we don't put any space between alphabets, or we can do it when we are naming esters. Like normally when we are naming esters, we would like to see where the alcohol is coming from and where the carboxylic acid is coming from. So we normally like use the separate spacing when we are naming esters. But make sure that you read these rules as provided on your exam guideline. The rules, I'm not going to explain them because we won't have enough time. They were already explained to you. The only thing, you go back and look at those rules that we use in order for us to name a specific compound. So you can see that everything that I'm discussing, I'm still on question number 2 of our organic molecules. Then question number 3 is only going to be about physical properties. What is it that you need to remember? We need to remember the definitions. These definitions of the 3 dependent variables that we have as our examinable physical properties needs to be remembered. You need to remember all the definitions because you don't know which definition will be part of your exam. You need to define the boiling point. I think you can even do it right now. You can define your melting point. You can define your vapor pressure. And as you know that these are your physical properties, they are the things that you are going to measure. They are the things that you are going to, they are the variables that you are going to determine. So immediately when they're saying that the variables that you are going to measure and they're the variables that you are going to determine, or they're the variables that you are going to investigate, I'm using all these verbs so that you know that they can say you can measure, they can say you can investigate, they can say you can determine. So immediately when you can do all those verbs, it means those are your dependent variables. It means they will depend on your independent variables, meaning that when we compare the physical properties, we will look at the independent variables that will affect our dependent variables. So what are these 3 dependent variables going to be affected? They are going to be affected by the chain length or mass or a molecular mass or molecular size, meaning that it means if you are changing the mass or you are changing the chain length, you can affect the boiling point, you can affect the melting point, you can affect the vapor pressure. So that is why we are saying the vapor pressure, the boiling point, and the melting point, they will depend on. That is why we are calling them the dependent variable. They will depend on the mass of the molecule, on the chain length of the molecule, because definitely you need to understand the relationship of the boiling point with the mass and the chain length, or you need to also understand the relationship of the boiling point, melting point, and vapor pressure with the surface area or the branch substance, and also the type of the intermolecular forces. So our dependent variables will definitely be depending on our independent variables that will be changing as we are comparing different compounds that the question maybe or the exam will be looking at. So it is very important that there is no way that you can choose mass or surface area or type of intermolecular force as the dependent variable. Definitely that cannot depend, the mass of a substance cannot depend on the boiling point, but the boiling point can depend on the mass. So you need to know immediately when you are given a question and they tell you that they are measuring the boiling point, or they are measuring the melting point, or they are measuring the vapor pressure, already the examiner is providing you with the dependent variable. The only thing that you need to find out as you are reading your statement is to say, what is it that they are changing to determine that boiling point, or what is it that they are changing to determine that melting point or vapor pressure. So it is very important that you know that when you are looking at the dependent variables, you are only looking at the 3 physical properties, that is boiling point, melting point, and vapor pressure, and our independent variable are as follows. And we already know that what is the relationship between the dependent variables and the independent variables. We know that as the mass increases or as the chain length increases, the boiling point is higher because the strength of the intermolecular forces is stronger. Also, in terms of the melting point, is the same as the boiling point, because as the chain length increases or as the mass increases, they will have a higher melting point because the strength of the intermolecular forces will increase. So those are the things that you need to know. But you know that vapor pressure will always be the opposite of the two, because as the boiling point is higher, the vapor pressure is lower. So it means when you increase the chain length, you are decreasing the vapor pressure, because the vapor pressure is going to be higher when the chain is shorter and the more you decrease the chain length, you are favoring the vapor pressure. So the vapor pressure, I was always referring to it as the opposite of melting point and boiling point. But melting point and boiling point, as long as the melting point is higher, the boiling point will be higher, but the vapor pressure will be lower. So those are the things that you need to go back and check whether you still understand, and how do we compare in terms of answering these questions. So these are the bullets that we can use on how do we compare, because as I advised you before, it is very important that you use bullet forms to show the comparison. So you will talk about the structure. You will say what makes the structures of the compounds to be different. Is it about the chain length? Is it about the branch? Or is it about the type of intermolecular force? So the structure will tell you what makes the 2 compounds or 3 compounds or 4 compounds that you are comparing to be different. You also look at the comparison of the strength of the intermolecular forces. As I already indicated, that the longer the chain, the stronger the intermolecular forces. That is the comparison in terms of the strength. So if you are given compounds and you are comparing them, it means you need to say something about the strength of the intermolecular forces, looking at the structure of those compounds. And also you need to also talk about the energy needed to overcome those intermolecular forces, meaning that you need to say, if you understand that the boiling point is high or the melting point is high, you will already know that you will need more energy to overcome the intermolecular forces, because those intermolecular forces will be stronger. But you know that if the intermolecular forces are weaker, it means you will have less energy needed to overcome those intermolecular forces. So what you need to know is the bullets. They are very important for you to answer, because the examiner will look at, did you say anything about the structure of the compounds that you're comparing, in terms of whether, in terms of their independent variable, what makes them to be different? What are you changing? What is not the same about the 2 things that you are comparing, or the 3 things that you're comparing, depending on how many things are you comparing. And also, did you compare the strength of the intermolecular forces after identifying the independent variable? And the last thing is, did you say anything about energy? So immediately when you answer this question, ask yourself a question to say, did I talk about energy? Did I talk about the strength of intermolecular forces? Or did I talk about the type of intermolecular, what is it, the energy needed to overcome those intermolecular forces? Then in our question number 4, we are going to look at our organic reactions. I know that anything can be asked anywhere in terms of this question number 1, number 2, number 3, and number 4, because actually they are one topic, but it is just demarcated for you to a little bit focus in terms of answering the questions. Question number 4 will look at the reactions. The reactions that we talked about is combustion reactions of alkanes. That was the first reaction that we talked about, and I tried to also explain to you how do we balance those reactions. So if you have forgotten how do we balance the reactions, you can even go back to the YouTube that we used previously on how do we balance these combustion reactions of alkanes, whereby we know that we are going to find alkanes reacting with oxygen to give us carbon dioxide and water. And already, because our products are the same for all this, so it means there is no way that you cannot be able to know the product. So it means the mark for the product, if you need to write the combustion reaction, is already known by you. You already know what is the mark for the product. So the only thing you need to know the formula of the alkane. And how do you find a formula of an alkane quickly? You know that you use CnH2n plus 2. If it might happen that the name is given but the molecular formula is not given, so you can use a general formula always to be able to find that molecular formula of that specific alkane. Just note that we only do the combustion reactions of alkanes. This is according to our exam guideline. Therefore, there is no need for you to stretch yourself and do combustion reactions of any other compounds except alkanes, which we know that those saturated hydrocarbons that have single bonds only. Then we also look at esterification. I think we know that esterification, it will only be undergone by the primary alcohols. So therefore, it means immediately when you are given an alcohol and they say it has undergone esterification, there is no need for you to think too much to say what type of an alcohol is this one. I know we already know that alcohols can be primary, can be tertiary, and can be secondary. Therefore, you know that esterification will always be undergone by the primary alcohols, the ethanol, the methanol, the propan-1-ol, the butane-1-ol, the pentane-1-ol, hexane-1-ol, heptane-1-ol, octane-1-ol. The reason why I'm ending at oct is because you already know that our longest chain according to the exam guideline is 8. Therefore, it means the longest alcohol that you can find undergoing esterification is octane-1-ol. Only if it is having a branch or whatever, but if it is no branch, it will definitely be octane-1-ol. And then we have carboxylic acid. We know they belong to the carboxyl group, and they will be reacting with alcohol. So we know the conditions. The conditions of this, they are very important, because for every reaction, you know that you need to know the condition, which is heat and what? And the concentrated sulfuric acid. So for every reaction, there are some of the reactions where I will not explain the conditions because of time, but where time allows, I will definitely give you some of the conditions of the reactions that are very important. Then we also looked at addition reactions, and we know that addition reactions, we will only look at the addition reaction of alkenes. Alkenes are the ones that are having what? Double bond. Therefore, only alkenes will undergo addition reaction, meaning that if you see a structure or a reaction where the alkene is involved, you need to know that only additional reaction will be undergone by an alkene, because we don't deal with alkynes. Because if an alkene undergo elimination, it means it must form an alkyne, and alkynes are not part of our exam guideline. Therefore, it means there will only be addition reaction of alkenes, because they also don't undergo substitution reaction because of being unsaturated. Then, which addition reactions did we look at? We looked at hydrogenation, where we're adding hydrogen. We look at hydration, where we're adding water. Hydrogen, a hydrohalogenation, where we're adding hydrogen halide, a hydrogen which is having a halogen, and halogenation, where we are adding halogens. And the halogens that we are adding all along, I think we already know by now that the examiner stipulated that is Br2 and Cl2, which are the examinable halogens according to our reactions. And what I did, I also said, because we know that we are going to have different addition reactions, what are the expected products for each and every reaction, so that even if anything goes wrong, you know that if it was addition, if it was hydrogenation, I will expect to find alkane as a product. If it is hydration, I will expect to find alcohol as a product. So you already know that an alcohol, for you to find an alcohol from an alkene, you need to add water, because water is needed for you to undergo hydration. So an alkene will undergo addition reaction and provide you with alcohol. And then we are going to have a hydrohalogenation, where we are going to find a haloalkane. But during hydrohalogenation, an alkene, after adding a hydrogen halide, which is HCl or HBr, it will form a halogen, but that halogen will have a one halogen, which is a haloalkane. And then if it is halogenation, which is gonna be adding Cl2 or Br2, the haloalkane that will be formed is gonna be two halogens. So if you see a haloalkane or haloalkane with two halogens, you already know that this haloalkane was formed during halogenation, whereby a double bond was broken and two halogens were added at the same time in that specific alkene. Therefore, that is why I just want you to know the expectations of every product that you are going to get after you have undergone these addition reactions. Then we also talked about elimination reaction. We said alkene must be one of the products that will be part of your elimination reaction, because during elimination reaction, we know that we are now moving from saturated to unsaturated, which is our strategy that we discussed, that I'm going to just talk about it quickly. And then the last one is substitution reaction, and in this one we only look at saturated compounds, which is alkanes, alcohols, and haloalkanes. We remember that this strategy of triple S, SU, USA, was one of the strategy that assisted us to know or to have the expectations of the product after understanding the reaction and also identifying the reaction that is undergone. So we know that if you have a saturated compound and you find the saturated compound as your product, it means the reaction was substitution. So that is why during substitution you will only find that the reactants will be saturated, and the saturated compounds are alkanes, alcohols, and haloalkanes. And then if the reactant is saturated and you find the product being unsaturated, you will know that you'll find elimination reaction. That is why I was saying during elimination reaction, we will expect to find an alkene, because we know that an alkene, and maybe we can also find alkynes, but definitely there must be unsaturated compounds that will be formed during the elimination. And then if the reactant was unsaturated and the product becomes saturated, it means it's addition. That is why when you look at my addition reaction, I'm having an alkane, an alcohol, and a haloalkane, to show that only saturated compounds will be formed after undergoing a addition reaction. Now, these are the conditions that I like to share with you or to remind you with, because they are very closely related to each other. Like the example of substitution, where we were having hydrolysis. When we are having hydrolysis as a substitution reaction, we know that there will be heat that is needed and there will be a base that is needed. So you need to differentiate it with the dehydrohalogenation, which is our dehydrohalogenation, which is our elimination reaction, whereby we need, so for the substitution reaction, which is hydrolysis, where we have found that a haloalkane produces an alcohol, we need mild heat, we need diluted strong base. I know that we talked about strong bases in the other topic of acids and bases, and then now they are now in a position where they are a little bit understood very well, because already we did all the topics. So the base must be diluted and the heat must be mild. But if you are looking at the elimination, you must heat it. It means the heat is a little bit high here, and the base must now be concentrated. The reason why I discuss these two is because they are almost close to each other, and it is easy for you to make a mistake in understanding them. Now, most of the conditions of the addition reactions, you will find that you will need water will be needed, and will need concentrated acids like concentrated sulfuric acid, or we will also need catalysts like during what we call hydrogenation. During hydrogenation, we need catalysts like platinum. So those are the catalysts, or those are the conditions that you can just go back a little bit and remind yourself with, because those conditions, they will definitely be part of your reactions. So make sure that as you are going to go back, know what type of reactions are required and what type of the products are going to be found for each and every reaction that you are going to look at. Now let's look at this activity, because after each and every topic that I just tried to summarize, I will just give you a little bit of an activity just to remind yourself. It's not going to be long activities because we don't have enough time to do everything, but definitely we need to see whether we can be able to answer some of the questions according to the exam. Let's say the question number 1.1 here, it says the name of the functional group of propanoic acid. Propanoic acid. So immediately, this is a recall type of a question. You need to recall the name of the functional groups, and already today I have reminded you with the name of the functional group. So you can see that the first one they say is formyl. Formyl definitely is not correct, because formyl is for the aldehydes. So even if the answer is incorrect, it will be incorrect for that specific question, but it can be correct for the other question. For now, it's incorrect because they're looking for carboxylic acid, which is propanoic acid. Carboxyl group, definitely, okay, we can say this one, it can be correct because we know that is carboxyl group. Carbonyl is for the ketones, we know is incorrect, and hydroxyl is for the alcohols. So this is how definitely you can find questions. So this is a question that will assist you to tune in. This question, if we ask this question at the beginning of the exam, definitely you start to gain confidence, because this is the recall type of a question whereby the things will. But remember, you need to firstly identify where propanoic acid belong to, in which homologous series, so that you can say, as it belongs to carboxylic acid, therefore it means the name of its functional group is carboxyl group. Which one of the following is the correct name for the addition reaction of water to an alkene? This is what we just discussed now. When you add water to an alkene, I think from the notes that I just given you, you can see that when we add water to an alkene, we find that it's gonna be hydration and the product is gonna be what? Alcohol. So the question is, what is the name of the reaction? Definitely number A is going to be correct because it's hydration. Hydrolysis is not an addition of water, but it's when we do what? A haloalkane changes and become an alcohol in the presence of a base. Haloalkane forming what? An alcohol. So this one is not a addition of water. And then dehydration. Dehydration is the removal of water from an alcohol. The removal of water. And hydrohalogenation is the addition of hydrogen halide. So definitely. So I want you hydrogen halide. I want you, even if when you look at different multiple choice questions as you are practicing for tomorrow, just make sure that if you are saying the answer is not correct, where is it correct? So that definitely the strength of the knowledge that you have for tomorrow can be more in order for you to answer any question that is provided in the exam, because that is definitely doesn't matter. And then when you look at this one, consider the following or the compound shown below. You can see that this one is about naming. And immediately when you see such a question, you just go back and look at the rules of naming and remember what is it that we said about naming. Already you can see we can identify our substituents, because here it was supposed to be hydrogens, but they were substituted by CH3, which is our methyl. So this is the methyl. This is another methyl. And this is our bromobromine. Therefore, now we're going to start, as we said, we're going to start looking at how do we name before we look at the options that the examiner has provided to us, because we need to be able to name this before we look at the options. Now you can see that the longest chain is 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 1, 2, 3, 4. So you can see 1, 2, 3, 4, 5. So you can see that the longest chain is 5. So if the straight chain is the longest chain, it is always easy for us to take the straight chain as our longest chain. Therefore, after identifying our longest chain, we know that now we have pentane, because this is such unsaturated. This is saturated, and we can see that it's a haloalkane. Therefore, we now need to number our carbon. If we number our carbon, we can see that when we start this side, it's going to be 1, 2, 3, 4, 5. So our bromine is in carbon number 2. When we start this side, it's going to be 1, 2, 3, 4, 5. Our methyl is in carbon number 2 again. So both methyl and bromine, they are occupying the same positions. There is no one that is occupying a lesser or a greater position than the other. So now the next thing that we look at carbon number 3. Both of them, as you come from carbon number 3, they are both. So there is no side that is mostly substituted. So what is our option now? So the only option that we have now is to look at Br and methyl, the bromine and the methyl. And now we are going to say bromine alphabetically comes first before methyl. Therefore, it means our bromine will be the one that is more preferred in terms of the numbering, or on the side where the bromine is the side that will be preferred in terms of the numbering. So it means we're going to take this 1, 2, 3, 4, and 5. And even if you can try and check the in terms of addition of the substituents, you will see that both of them, they will give you 7, 7, both sides. You can even try that. And by that, you can see that now they will need you to go to another option except the addition of the substituents. Therefore, that is why the bromine take the alphabetical preference. So immediately when you say 4 bromo, already is incorrect, because we know that our bromine is in carbon number 2. Then 2 bromo, and then this is 2 bromo 3, 4, 3,4 dimethyl pentane. Definitely this is going to be correct. And then this one started by naming, but it didn't look at the naming alphabetically. Even this one, even if this one was supposed to be correct, is incorrect because it started with methyl. Remember, we always name alphabetically, and we know that di is just to indicate the number. We don't include di in terms of alphabetical preference, in terms of naming. So that is why our correct answer is number B, 2 dash bromo, or 2 hyphen bromo hyphen 3,4 hyphen dimethyl pentane. And this question, if it was a long question, it was going to be provided 3 marks, but now because it's on the multiple choice, it is provided 2 marks. The letters A to D in the diagram in the table below represent 4 organic compounds that belong to different homologous series. The first thing that you need to do when you are given a table like this, make sure that you identify where does each compound belong to before you can start answering the questions. So you can see that we have 2-methyl propanol. We know that this one belongs to the aldehyde. This aldehyde is having what aldehyde? Is having a branch. And then you can see that this one by CH3COOH is a carboxylic acid. And then this one by the triple bond is an alkene. And then this one is an alkane by ANE. Therefore, if you can do that, already you can even go back and say, I am given a name. Definitely, I think I need to know how do I draw a structure, the structure of the name. If you're given the structure, you need to know the name of the structure. And even here, we are given a structure, a condensed structure. We can write the name. We can also write the structural formula. And then here we are given a name. We can draw the structure. So the first thing says define homologous, which we can all do at this point in time because I said definitions are important. And then write down the letter that represent a saturated hydrocarbon. We know hydrocarbons are compounds of hydrogen and oxygen, are compounds of hydrogen and carbon, and they are only alkanes, alkenes, and alkynes. And according to them, they are different in terms of the number of bonds that they are having, because alkanes have single bonds only, alkenes double bond, and alkynes triple bond. So we refer to them as the hydrocarbons. So the only saturated hydrocarbon, according to our compounds given here, is only D. This is another hydrocarbon, but definitely is unsaturated. It cannot qualify to be the answer for 2.2.1. And then general formula of the homologous series to which C, where is C? C belongs, is here because of the, already we have identified it that C belongs to the alkynes because of the triple bond. And then structural formula of compound A. Already we said this is an aldehyde. This aldehyde is having 3 carbons. And in the second carbon, we are having what? We are having a methyl. And then we know that is aldehyde. Then it's H. I can just write H. And then we know that aldehyde, they have CO and then H at the end, because this is the structure of the functional group of aldehyde. And then compound D has 3 structural isomers, and then they say to you write down the structural formula of the isomer with the shortest. This is one of the questions that needs a more insight of from you. So if you say this is the pentane, because it's our compound D, therefore we know that pentane is 1, 2, 3, 4, 5. So if you want a smallest isomer of pentane, it means is that pentane that will be, after drawing that pentane, there is no any other structure that we can draw. So we need to branch it in such a way that it will never form another compound except this, which is the last one, is the shortest. And it's going to be like this. So we are going to make the 2-methyl to go to carbon number. So it's going to be 2,2 dash dimethyl what? Propane, which is this is the shortest. Normally we normally look for the isomer, maybe they say of the longest chain becoming 4. So the longest chain here is gonna be 3, and we're gonna have dimethyl. And then the last one say balance, write down the balance equation for the combustion of D. Our D we know is our alkane, which is pentane, so we know it's C5H25 plus, okay, 5 plus 2. So it's going to be C5H12. So it means now we already know the molecular formula, and we can now write the balance formula, which is going to be C5H12 plus O2, giving us carbon dioxide and water. Remember, how do we balance? We have 5 here, so we're going to put 5 here. The number that follows 5 is 6. Then we try to balance our oxygen on the other side so that we can divide by 2 on the right hand side, which is going to be 5 times on the left hand side, which is going to be 5 times 2, which is going to give us 10, plus 6 times 1 is going to give us 6. So we have 16. So it means 16 divided by 2 is going to be 8. So our formula is going to be C5H12 plus 8O2, giving us 5CO2 plus 6H2O. This is what I said you must go back and revise, because we definitely did the revision of this. Then let's look at question number 3. As we said, question number 3 is going to be based on the physical properties. We are provided a graph here, and our graph is having 2 lines that represent alcohols and ketones. The graph below shows the boiling points of straight chain primary alcohols and straight chain ketones with different number of carbon atoms. So already we know that our alcohol and our ketones, they are both having straight chains. They are not branch. And then the next thing is, so when you look at the graph, you can see that we are given alcohols of different carbon, because the independent variable is our number of carbon and our dependent variable is our boiling point. So you can see that now the chain length is our independent variable in this regard, because that is what is making our alcohols and our alkanes to be different in terms of looking at what makes them to be different. But what is nice is that they are given the same number of alcohols of the same number of, because their chains, as their chain length increases, or they are increasing the same way. Now, the first thing is define a boiling point, which is something that we need to all do at this point in time. We need to all be able to define a boiling point. Explain why the boiling point of alcohol increases as the number of carbon atoms increases, by referring to the type and the strength of the intermolecular forces. Already they are telling us that the boiling point of alcohols, we can see that the graph is increasing. For the alcohols, it's increasing. 3 is here, 4 is here, 5 is here, 6 is here. So as the number of carbon atoms increases, we already explained that as the chain length increases, the strength of the intermolecular forces increases. That is the first thing that you need to understand about this alcohol. So the number, it means now what is happening here is that as the strength, as the chain length increases, also the London forces of this specific alcohol increases, making that the boiling point of this alcohol to be higher. So the longer the chain, the stronger the intermolecular forces, the higher the boiling point, because the London forces and the hydrogen bonds, it means they are increasing as the number of alcohols are increasing, because we know the type of the intermolecular forces that alcohols have. They have hydrogen bonds, one side of hydrogen bond, and we know the ketones have what? Have dipole forces. So the 2 marks is about the London forces will increase, or the strength of the intermolecular forces. The longer the chain, the stronger the intermolecular forces, because alcohol is having London forces plus dipole forces plus a hydrogen bonds, which will increase as the chain length increases. So the type is the type of intermolecular forces that alcohol is having, which is the hydrogen bonds. Explain why the curve of alcohols is higher than that one. Definitely this one is explained by what I just explained now, to say alcohols have one side of hydrogen bond, whereas, so now they want you to refer to the type and the strength of the intermolecular forces. So the type is that alcohol have one side of hydrogen bond, whereas ketones have dipole. You know that I only mention what is outstanding. I don't say London, dipole, and hydrogen. I just mention hydrogen bonds because they're the ones that are outstanding in terms of the alcohols. And then the ketones, dipole. Therefore, what is it? Hydrogen bond are stronger than dipole forces. Therefore, more energy will be required to overcome the strength of hydrogen bond of what? Of alcohols. We know that we can even answer in terms of the dipole, but for now we know that it will just be an opposite. Now, the vapor pressure of alcohol is compared to that of ketones. Immediately when we have concluded to say alcohols have higher boiling point, we already know that alcohols will do what? Will have a lower vapor pressure. If we were comparing it with the ketones now, it means now the ketones will now take the stand and have a higher vapor pressure as compared to alcohols. They say, why must alcohol and ketones, which are used to prepare comparison, have the same molecular or the same number of atoms? Definitely this is an experiment, and Every time when you do an experiment, you need to make sure that whatever that you're doing, there are no many questions about to say there is unfairness. So the reason why we are making sure that then the same number of carbon atoms are used is because we want to make a fair test. We want the test to be fair, so that we don't say the alcohol is having a higher boiling point because it's having more carbons than the ketone. So always we need to compare the things that are having, we need to have controlled variables. When you're controlling the variables, we are making sure that our tests become fair. So because of the fair test, that is why alcohols and the ketones, they will use what? The same number of carbon atoms whenever we are comparing them. And then which one of the or which one will have the higher vapor pressure, alcohol or ketones? And we have agreed that in this case now, ketone will have a higher vapor pressure, because at the top we have seen that ketones were having what? A lower boiling point. So they say give a reason for your answer. That is what I was giving, to say the lower the boiling point, the higher the vapor pressure. So as we have discovered that ketones, they have dipole forces which are weaker than hydrogen bonds. Definitely ketones will have a higher a vapor pressure than alcohols, as we are comparing them here. But if it was alkanes, definitely alkanes we're gonna have a higher, or the ones that are having London forces only, like our hydrocarbons, alkanes, alkenes and alkynes. If I was comparing ketones with those, definitely ketones in that instant was going to have a higher boiling point. But because I'm comparing it with alcohol, ketone now is having a higher vapor pressure. Now, let's look at question number 4, where we normally look at our reactions. When you look at this, we can see that compound P, we are given a flow diagram. Compound P can be used to prepare organic compound R, this organic compound, this R. Then NQ, as shown in the flow diagram below. Now, immediately when you look at the flow diagram, there are things that you need to think about, especially when you are given some clue. You can see the first thing that you are told that here we are going to find a halo alkane. And if you are going to find a halo alkane, we are having an alcohol. So what are they adding? They are adding ACl in this alcohol to find this halo alkane. So the first thing is that I'm moving from an alcohol which is saturated. I'm going to an halo alkane which is also saturated. Therefore, it means reaction 2, as provided in the exam, it means it's going to be my substitution reaction. So I know that I'm going to substitute something so that I can get that halo alkane. And you know that alcohol, if you want to move from an alcohol to a halo alkane, the only thing that you're going to remove the OH from the alcohol and put the halogen instead of an alcohol. That is what you need to understand before you can start this reaction. And then we can see that here our alcohol is going to be reacting in the presence of sulfuric acid to form this. What is this? This is our ester. And we know that when an ester is formed from an alcohol, that alcohol, it means it must have another reactant in the presence of sulfuric acid as our catalyst or as our dehydrating agent. Therefore, it means now we are going to do what? We are going to look at this sulfuric acid, because it's the one that is going to be needed in this reaction. So they're saying in reaction 1, alcohol P reacts with another organic compound in the presence of concentrated, as I was saying, and we know that that must be a carboxylic acid, because it means this reaction definitely is going to be our esterification, whereby an alcohol, and we know our alcohol is going to be our primary alcohol. Already we know, because we said esterification can only be undergone by the primary alcohols. Therefore, name the type of reaction that is represented by reaction 1 is our esterification. Now let's look at our ester. This ester can be able to assist us to identify the alcohol and the carboxylic acid that reacted, because when you look at it, it is condensed. I always say you take this oxygen and make sure that it separates these two sides, the side of the alcohol and the side of the acid. So if it is CH3, CH2, CH2, and then O, and then C, double bond O, and then CH3, you can already see that it means our alcohol is coming from the alcohol with 3 carbon, which 3 carbon atoms, which is going to be our propane 1-ol. Why am I saying it's propane 1-ol? Is because, okay, let me just erase this one. I'm saying it's going to be our propane 1-ol. Okay, take that one. Let me just erase this part. Okay. It's propane 1-ol because the alcohol is already having what? Our alcohol is our primary alcohol, so it's going to be propane dash 1 dash ol. So I already know my alcohol, and if I look at the structure, there are 2 carbons that are left. It means my carboxylic acid is going to be my ethanoic acid. So I think we already know that from the structure of the ester, we can identify the alcohol and we can also identify the carboxylic acid. And because this is an ester, we know that it can also have some functional isomers. And the functional isomer of an ester, we know that are carboxylic acid. So in terms of that, you just count the number of carbons and it will give you the carboxylic acid that can be its functional isomer. So now, number 1 says, beside the presence of a catalyst, write down another reaction condition for reaction 1. We know that we need sulfuric acid, but as I was explaining the conditions of esterification, I also indicated that we also need heat, because as we were doing this experiment, I think this is one of the experiments that most of the school conducted, and you saw that you were heating the mixture as you were combining it, this alcohol, the sulfuric acid, and the alcohol, the carboxylic acid, and the sulfuric acid. The mixture was also heated. So heat is one of the conditions that is needed for esterification to occur. And then the structural formula of alcohol P. So it is not going to be a problem or a challenge for us to write the structural formula of alcohol P, because we know that only primary alcohols will undergo esterification. So the structural formula is going to be our propane 1-ol, which is going to be our C3 carbons, and then we add the hydrogens and the OH, which is our hydroxyl group. And then IUPAC name of compound R. Our R is coming from propane 1-ol and ethanoic acid, so therefore it's going to be propyl from propanol, and then ethanoate from ethanoic acid. I think this one, if you can get such a question, maybe most of us can be able to get many marks in. And then IUPAC name of a straight functional isomer. As I said, immediately when they give you a carboxylic acid, you definitely need to know, or an ester, you definitely need to know the functional isomer of that ester, or the carboxylic acid, the functional isomer of that carboxylic acid. So in our case here, we are given an ester and they want the functional isomer of this ester, which we know that esters are functional isomers of carboxylic acid. So it means we are going to have what? Pentanoic acid as our functional isomer. Then this one says we still have this alcohol. It says for reaction 2, write down the type of reaction that takes place. We agree that is substitution. And then the inorganic product. Definitely, if this alcohol, the propane 1-ol, react and then it is substituted with HCl, with Cl, so it means this OH will be removed, and then in this case we're gonna have, it's gonna be replaced, we're gonna have what is it, Cl here, and so it means water will be one of the product, which is OH, and 1 hydrogen from the haloalkane that will be removed as we were putting the Cl instead of the OH. So we are going to have our water as one of the inorganic product. And then the condensed structural formula of Q, our Q is going to be definitely our halogen. And then we can put our Cl here because it was from the primary alcohol. So the condensed, it can be CH3, CH2, and then CH2, and then Cl, which is going to be our condensed structure of our, you can write it in any way. You can start on the other side. It doesn't matter as long as all the compounds are. Then a primary alcohol that contains 3 carbon atoms. is converted to a secondary alcohol. I think this one we need to understand now that as we are converting a primary alcohol to a secondary alcohol, they still belong to the same homologous series. However, because they are both saturated, we cannot just take the OH and put it on the second carbon, because that is not allowed. We need to now start and think about changing the primary alcohol to something else so that that thing can change to a secondary alcohol. So what is going to happen here is that our primary alcohol will undergo step 1 and form compound Q. Our compound Q will undergo step 2 and form our secondary alcohol. Therefore, the next thing that you ask yourself, how can I find an alcohol? It doesn't matter whether primary or secondary, but how can I find an alcohol? The next thing that you think about is that I can only find an alcohol from an alkene, whereby an alkene will undergo what? Hydration. So it means P is an inorganic reagent, as they are telling you, while compound Q is organic. So they're saying this primary alcohol must react with something that is inorganic, that must undergo what, and then this, so that this Q can be formed. Therefore, it means now you need to think further to say, what can I make alcohol to react with so that I can find P, which is my alkene? Because definitely this must be your alkene in order to find a secondary alcohol. Otherwise, there is no way that we can find a secondary alcohol from this alcohol if we don't have an alkene that will undergo hydration. So it means now P, they're saying write down the formula of P. The formula of P, for an alcohol to be an alkene, it must lose water, it must undergo dehydration. And what will make dehydration to occur is sulfuric acid. So P is our concentrated sulfuric acid, H2SO4. And then one reaction condition for step 2. Step 2, remember, is when now an alkene change and become a secondary alcohol. So you will need what? For step 2, you will need excess water here. You will need excess water because this is going to be a hydration reaction. So excess water is needed. Sometimes you will also need what? You will also need an acid, a strong acid like sulfuric acid or sulfurous acid in this reaction. But definitely it must not be concentrated. It must be diluted in this regard. And then balance equation for step 2 by using a structural formula. So you will use an alkene. Already we know that an alkene is going to have also 3 carbons because we're told that our primary alcohol is having 3 carbons, and that alkene is going to be propene that will undergo hydration, and we're going to add water. And as you're adding water in propene, we are going to use our Markovnikov's rule, whereby the hydrogen will go to the carbon with more hydrogen and the OH will go. So that is why at the end of the day, you'll find that the alcohol that will be formed is going to be our secondary alcohol, which is going to be our propane 2-ol. Before we go to the question number 5, I would just like us to have a 2 minutes, a short break, so that we go and extend to question number 5, because we have talked so much in terms of organic molecules. Just for 2 minutes, we'll just come back and continue with our question paper for 2 minutes. Welcome back, grade 12s. I know that this is a very short and very demanding session for you because you are anxious about tomorrow and you don't know what is going to happen. But be rest assured, as long as you have all the information that you need, the examination is not a problem. So as you can see, the last question that we did on organic chemistry, in terms of the reactions, you can see that there are lots of things that an examiner can ask you about. The only thing that you need to know the information that is given to you by your teacher and the exam guideline. Because the last question of 4.2, you can see that for us to get a secondary alcohol, we removed water from the primary alcohol. To get an alkene, we added water to an alkene to go back and get the secondary alcohol. So as long as you know how things are done, as long as you know the products that each and every reaction must give you, you won't have a problem to understand that how do I move from a primary alcohol maybe to a secondary alcohol. What is it that can give me a secondary alcohol? And you know that during our addition reactions, always we normally get our secondary alcohol. So our addition reactions will always give us our secondary alcohols because our addition reactions will always follow the Markovnikov's rule. So we will just ask ourselves, how do I get a secondary alcohol? I need to add water to something. And what is it that I can add water to for me to get an alcohol? I need to get water to an alkene so that I can get an alcohol, because you are given an alcohol. So it means you must remove water from that alcohol to get another alcohol, which is a secondary alcohol. Then reaction 5, question 5 is about rates of reactions. So what is it that we need to understand about rates of reaction? Definitely we need to define the rate of reaction. We also need to know the factors that affects the rate of reaction. But just know that the examiner will not say to you list the factors. The examiner will expect you to explain the factors using the collision theory on how each factor affects the rate of reaction. We are not going to spend a lot of time in this question because as I'm looking at the time, our time is not on our side. But what is it that is important when we are explaining factors that affect rates of reaction according to collision theory? We know that temperature is one of the factors that affects the rate of reaction. So what does the temperature do what does the increase in temperature do in the chemical reaction? The temperature will increase what? Will increase the average kinetic energy of the particles. So if an examiner is asking you a question and it is based on temperature and say how does temperature affect the rate of reaction, you will know that you will need to talk about temperature increasing the average kinetic energy of particles. And whereas concentration, it increases the number of particles per unit volume. And the catalyst do what? Provide the alternative pathway for the reaction to react. So the reason why I'm giving you this is because you need to know what does each factor do in affecting the rate of reaction. So temperature increasing the average kinetic energy, and then concentration increasing the number of particles, and then catalyst. And you know that we are only looking at the factors that increase the rate of reaction. So we are only looking at the positive catalyst in this case, positive catalyst that you're going to look at, that will provide an alternative pathway for the reaction to react. Therefore, in question number 6, we are also going to look at chemical equilibrium. We know that we define a closed system. We know that we look at Le Chatelier's principle. We calculated Kc, which is sometimes a pain in most of us. We know that Kc doesn't have units. Apply stoichiometric calculations, of course, when you are calculating Kc, and explain the meaning of Kc value and use Le Chatelier's principle to explain the shift of equilibrium. So this is what we need to also understand when we're looking at our question number 6, which is our chemical equilibrium. Now, I decided to just take one of the questions under chemical equilibrium so that we can see how can we answer and remind ourselves how do we answer the questions. The following reversible reaction, and we know that what do you mean by reversible reaction, can be used to demonstrate how certain factors influence chemical equilibrium. So you can see that this is a combination of question 5 and question number 6, because we know how which factors affect equilibrium, and some of the factors definitely they won't affect chemical equilibrium, but they are the factors that affect the rate of reaction. We are having COCl4 2 minus aqueous plus 6 H2O liquid giving you COH2O 6 2 plus plus 4Cl minus. The colors of these ions are given. The cobalt chloride ion is blue, and this one cobalt hydrate is pink. Therefore, they say define the term reversible. I think by now the terms of definitions were explained to you, and you need to know what you mean by reversible without confusing it with reverse, and it's for 2 marks. Initially, the solution is blue. So they're saying initially the solution is blue in color. Immediately when they say the solution is blue, you can think about which side is favored. You can see that the reverse side is blue and the forward side is pink. So initially they're saying the solution is blue. They're saying write down either turns more blue or turns more pink to describe what happens to the reaction mixture if some cobalt chloride ion, cobalt tetrachloride ions are added. So if you are adding more of this cobalt tetra, which side is going to be favored? Number one, you already know that if this was blue, therefore it means if we're adding this side, we are favoring the forward side. So it means this side will turn what? More pink, because it means we are favoring what? The forward reaction. As we are disturbing the reverse, the reaction will shift to the right and favors the forward reaction. And then if we add HCl, we can see we are now increasing the chlorine in this side. So it means now our reaction will do what? Will favor the left hand side, which is going to be our blue color. So we need to just remember how does the factors affect these reactions. Then the test tube containing this mixture is placed in hot water, and it's observed that the solution is turning more blue. Is this an exothermic or an endothermic reaction? We expect that if it is endothermic, then it means that the solution must turn pink. Therefore, if it is turning blue, it means it is favoring the reverse reaction, which is going to be our exothermic reaction. So they say explain by using the Le Chatelier's principle, which is what I was doing now. It means as our solution is turning blue, it is favoring the reverse reaction, and the reverse reaction is exothermic reaction. Therefore, that is why we end by saying the exothermic reaction is going to be the one, our forward reaction. It means it's going to be our exothermic reaction, because it means it's favoring this side that is turning the solution to be blue. Then they're saying explain the answer. Okay. Now, what is my interest is this question more than any other question that we just discussed right now. They are giving you the number of molecules of N2O4 gas, which is sealed into a 4 cubic decimeter container and then heated at 400 kelvins. Now they're saying the following balance equation represent the equation at equilibrium that in the container at 400. So we are having the balance equation N2O4 going to 2NO2. Now, what you need to remember is that when I started explaining the issue of stoichiometry with you, I also gave you different options or different formulas that we can use to calculate the number of moles, because I think we already know that it is always easy to work with number of moles in such questions. And there was one formula that I provided to you that says a number of moles is equal to the number of molecules divided by the Avogadro's number. And we also explained that our Avogadro's number is 6.02 times 10 to the power 23 particles. So we already know that if we are given the particles and the molecular formula, we need to definitely in one way or another find the number of moles. So we are given these particles of N2O4 and we need to calculate the number of moles. So they're saying these particles are still in this container. As I said, the following balance equation is provided. At equilibrium, it is found that 0.4 of N2O4 have decomposed, meaning that from whatever that we had before at equilibrium, what decomposed was 0.4. So it means what was used, it was 0.4 from what we had initially. I think in this regard, we are not going to confuse this 0.4 as what we found at equilibrium. But we have found that after reaching equilibrium, we find that 0,4 has decomposed. So it means 0,4 was already being used before we reached equilibrium. It is not what was left at equilibrium, but it was what we found being used as we reached equilibrium. So they say calculate the equilibrium constant. This is very important for us to understand, because we now need to understand how do we calculate the equilibrium. So the table is still handy for us to use even in calculating this, because we are having our N2O4, and then we are having our NO2, and then they are reacting as in a ratio 1:2. And then it means we will start and say the initial number of moles used or produced, and then moles at equilibrium, and then concentration at equilibrium. That will assist us to calculate what? Kc. If you use this information to find the number of moles that we want initially, you will find that I think the number of moles was 0,5. If you use your calculator using the Avogadro's number and finding the number of moles was 0,5. And we are told that the number of moles that was used was 0,4. And then it means now the number of moles at equilibrium is going to be 0,1. Then we know that, as we know that we started with 0 here, but we know that what was used, it was 0,4 from N2O4. So it means it's 1:2. So it means if here we're having 0,4, here we are going to have 0,8 according to the ratio. And then it means also you are going to have 0,8. You can just calculate it and check if you are getting the same answers, because we won't have enough time to go through everything. And then here everything is going to be divided, 0,1 divided by 4, 0,8 divided by 4, which is our volume that was provided to us. And then is then now you can now start and using, after getting the concentration here, is the one that you are going to use now to our Kc, which is going to be the concentration of NO2 squared divided by the concentration of N2O4, which is to the exponent 1, because we didn't have. And then you can calculate the value of your Kc. But what I wanted to explain more is this 0,4, to say it is found that 0,4 decomposed, meaning that this is not what was left at equilibrium, but this is what was used. And we found that when we reach equilibrium, from 0,5 we have used 0,4, so we are left with 0,1. So it is very important to understand the language of the examiner that they've used here in terms of what. So here we know that whatever answer that we got here, we're going to substitute here. We're going to substitute here. And whatever answer that we got here, we're going to substitute it here. And we find our Kc. Making sure that our Kc, we don't put any units, because Kc do not have units. Then question number 7 is going to be our acids and bases. And we agree that whenever you see a question that you feel that you have more strength on it, just jump to that question so that you answer it as you remember everything about that question. We defined acids and bases according to Lowry-Bronsted theory and Arena's theory. We did that in our previous lessons. We identify acids and bases in terms of strong, weak, in terms of concentrated and diluted, in terms of monoprotic or diprotic, and we also identify acid-base conjugate pairs. So this is the information that you need to make ready for tomorrow before you start answering your question. Now, we also use stoichiometric calculations, and we do some of the calculations under stoichiometry, exactly the same as the one that you just did now, but you are also going to be expected to perform some of the calculations under acids and bases. And then we are also going to calculate the pH, just like Kc. There are no units for pH, so make sure that you don't use wrong information or give wrong units for the pH. And then we are going to copy formulas from the data sheet correctly in order for us to perform calculations under acids and bases, especially for the pH and also for the calculation of number of moles or volume or whatever, or dilution. Now, the equation below shows the reaction occurring in hydrochloric acid and ethanoic acid solutions. Both acids have concentration of 1 mole per decimeter cube. So it means the concentration of ethanoic acid and the concentration of hydrochloric acid is the same. They have both same concentration and are kept at 25 degrees Celsius with the same temperature. Then reaction 1 is hydrochloric acid reacting with water to form a chloride ion and hydronium ion. And we are provided a Ka value which is 1,3 times 10 to the exponent 6, which is positive 6. And then ethanoic acid reacting with water also to give us ethanoate ion and hydronium ion. And here our Ka value is 1,8 times 10 to the exponent negative 5. So you can see that Ka value here, the Ka value here is greater than 1 and the Ka value here is less than 1. So already they are telling us about ethanoic acid and hydrochloric acid. So the first information that you will know, because we are given, it means this one is a strong acid whereas this one is a weak acid. And what gave you that information is the Ka value. The examiner didn't explain whether hydrochloric acid is strong or weak, but they just gave you a Ka value. Now they say define an acid according to Lowry-Bronsted theory, which is what we need to know by now, without confusing it with Arenas, because each definition has its own a way of explaining an acid. So you need to, if they say Lowry-Bronsted, you need to define an acid according to Lowry-Bronsted. And then write down one conjugate acid base pair of reaction 1, which is this one. So we know that if we want a pair, it can be HCl and what? And Cl minus, or it can be H2O and what? And H3O plus. Both of them, they are correct in terms of the acid-base conjugate pairs in reaction 1. Then which solution 1 or 2 will have the lower pH value? Now explain your answer. Now this question can only be answered by what is provided to you by the examiner. Now the first thing you need to identify which acid is strong between hydrochloric acid and ethanoic acid. And we have already identified that hydrochloric acid is strong, ethanoic acid is weak. What information was given to us to identify that? It's not the definition, but it's the Ka value. So we are going to say reaction 1 is our reaction 2 is going to have our, I'm right when I say reaction 1, lower pH is going to be lower pH is going to be reaction 1. Remember, as the stronger the acid, the lower the pH. And we know that hydrochloric acid ranges there, somewhere there, 1, 2, 3 pH. So it's reaction 1 because it's having the Ka value is greater than 1. Ka value greater than 1. So if the Ka value is greater than 1 and it's a strong acid, you can say it's a strong acid. Ka value is greater than 1 and it's a strong acid. And we know that if it's a strong acid, the Ka value is greater than 1 and the pH will be lower. Then 10 cubic centimeter of 1 mole decimeter cube of sodium hydroxide solution is diluted with water until pH 13 is reached. Calculate the number of moles of sodium hydroxide in 10 cubic centimeter initially in the solution. So we just want to know how many moles are there in 10 cubic centimeter of sodium hydroxide solution in water. So we know the number of moles. We are going to use what? We are given the molar mass. We are given the volume. We want the number of moles. So we can calculate it by saying, and you must always make sure that if we say we calculate the number of moles, we know that if we are given cubic centimeter, we must divide by 1,000 for us to find cubic decimeters, because in terms of the concentration, the units of concentration is mole per decimeter cube. So we are going to say C is equals to N over V according to the table, the data sheet, whereby N is going to be C multiplied by V. So the concentration is given as 1, and then we are going to say multiply by 10, which we are going to divide it by 1,000, and we are going to find our number of moles as 0.1 mole of sodium hydroxide. as you are going to use your calculator, you are going to see that you are going to find this answer. And then calculate, okay, what is it? Oh, we're calculating the number of moles, which is 3 marks. Calculate the volume of the diluted sodium hydroxide in mole per decimeter cube. Immediately after getting the number of moles, and then we are saying they're looking for the volume of. So immediately when you have the number of moles of this, you can calculate the volume of the diluted. This is the initial number of moles. This is the initial concentration. So for dilution, you can even use the formula C1V1 is equals to C2V2. And then you know that the concentration before it was 1 multiplied by the volume, and it was provided to you as it was, I think it's going to be 0,1 or 0,01. And then this one, you are looking at the concentration, you are looking for the second concentration, which is going to be at the volume, and then the volume of number 2. So because we definitely don't have enough time, we are going to say, as we are going to have the number of moles, I want us to look at this one. As we know that we are having the number of moles, we are going to use the information that was provided to us as the pH to calculate the concentration of sodium hydroxide, which was 0,1, as we are going to use pH. How do we find it? We are going to say pH is equal to minus log, and then the pH is given to us as 13. We are going to find the concentration of, this one was provided to us, of the H2O plus. We are going to find this one of the H2O plus, because we are going to find it by using this pH calculation. And then we find the Kw to find the pH of OH, which is going to be the pH of sodium hydroxide. Now, why are we saying the pH of OH is the same as the pH of sodium hydroxide? Is because sodium hydroxide is a strong base. Therefore, the concentration of OH is going to be the same as the concentration of NaOH. And then after finding the concentration of NaOH, therefore we can use this formula, C1V1 is equal to C2V2, to find this concentration. I'm looking at the time. The time is not on our side, but what is going to happen after finding this concentration, we're going to now find the volume of the diluted sodium hydroxide in this solution. But the only thing that will assist us is finding the concentration of H3O hydronium ions. That will assist us to find the concentration of hydroxide ions, which will assist us to find the concentration of the second concentration of sodium hydroxide, which was 0,1, using the pH value that was provided to us. Now, the last two questions are about electrochemical cell, which is galvanic and electrolytic. And we know that we need to know energy conversion in a galvanic cell. We need to know that there are exothermic reactions, there are spontaneous reactions. We know the definitions of oxidation and reduction in terms of electron transfer and in terms of oxidation numbers. Definitely the time will not be enough to explain everything that we want to explain with these questions. We also need to know and identify the electrodes, which are anode and cathode in a galvanic cell. Understand what do you mean by inert electrode. Normally in a galvanic cell, we explain that we use platinum. Use the reduction potential table to identify oxidation and reduction. And then write the half cell reaction with small potential value that will undergo oxidation using the reduction potential table, of course. Write down the overall net reaction and the cell notation of the galvanic cell, and calculate the EMF of a spontaneous reaction, which is only the EMF of a galvanic cell will be calculated. Making sure that we copy formulas correctly from the data sheet without using the abbreviations. That was emphasized. Now, we are also going to understand what happens to the two half cells, which is oxidation and reduction. Know the standard conditions, which is temperature, concentration, and pressure where there are gases. And then function of the salt bridge, movement of ions, which are anions and cations in our internal circuit in a salt bridge. And then also know the movement of electrons at the external circuit, where we know that they will move from the oxidation side to the reduction side, or from the anode side to the cathode side. Note the physical changes that occur when you observe each cell in operation. Understand the meaning of the voltmeter reading 0 where the cell reaches equilibrium, and also know the decrease. I think we also need to know the decrease of the EMF, what makes the EMF value to decrease in each reaction which is in operation. Now, this is the standard cell reduction potential table that we normally use, and normally in our case, we normally use table 4b, and this is the table 4b that was snapshot from the entire table. Now, this is the question that I chose just for us to make revision on. A galvanic cell setup under standard condition using a cell A and B shown below. Cell A is given this half cell notation and cell B also have this half cell notation. What is important is that for each half cell, you need to see which spaces are given. Like if you look at this one is Cu and Cu2 plus. So immediately when you go to your standard reduction potential, you need to look at the half cell that will give you Cu and Cu2 plus. Also, when you look at this one, is having H2O, O2, and H plus. Also, when you go to your standard reduction potential, you need to make sure that all these bases are specified on that specific half reaction. Now, they say define oxidation in terms of electron transfer. As we said, that you will be asked in terms of either electron transfer or oxidation number. Write down the initial concentration of H plus in aqueous solution. So if they say write down the initial concentration, the examiner told you that this occur in standard conditions. So it means all our aqueous solutions or all our electrolytes will have 1 mole per decimeter cube according to the standard condition. So the concentration of H plus is going to be 1 mole per decimeter cube because this reaction occur at the standard condition. Name of the metal used for electrode B. When you look at electrode B, we have liquid, we have gas, we have aqueous. We don't have any solid or any solid metal. Therefore, we have agreed that in cases like this, we are going to use our platinum as our inert electrode that will assist in terms of transferring the electrons from the side of the anode to the side of the cathode, or from the oxidation side to the reduction side, because it's a good conductor of electricity and it is non-reactive in this reaction. And then the formula of a reducing agent. You can only calculate the formula, you can only identify the reducing agent if you know that between these cells, but now in terms of our case, it's going to be platinum. Between these half cells, which one will undergo reduction, which one will undergo oxidation? So as you can look at these two half cells, this is the one of copper. And for the water one, this is the one for water and oxygen. So you can see that it means here copper will undergo oxidation reaction, and the water O2 plus 4H plus 4 electrons will undergo reduction to form 2H2O. So already you know that if you want to identify your reducing agent, you must identify it on the site where you are having reducing agent, which is the site of copper. So because copper undergoes oxidation, it means our, okay, let me just go back. It means our reducing agent is going to be Cu, because it is the anode, is the electrode that we found at the oxidation site and is our anode. And then the reduction half reaction, I think I've already written the reduction half reaction because I'm going to take it exactly as it is from the table of the reduction potential, which is where we are going to have oxygen plus 4H plus 4 electrons giving you 2H2O. Let me go forward. And then, so it's going to be O2 plus 4H plus 4H electrons giving you 2H2O is our reduction reaction, which is qualifies for 2 marks. And then the overall balance reaction, we are going to add the 2 reactions. So as you can see that here we are having 2, here we are having 4. So we can even say we are dividing by 2 here. So it's going to be 2H plus and 2 electrons there and H2O. We're going to just take the LCM because the difference is 2 here. But we can still multiply by 2 and find still the LCM as we are finding the net reaction by making sure that the number of electrons both sides are going to be equal and then cancel each other. And then we're going to have a Cu and then plus what, O2 plus 2H plus giving you Cu2 plus plus H2O. Remember, it's because they have cancelled each other as we are doing the reactions, as these two electrons were reacting. And then this one is also a galvanic reaction. The graph below shows EMF of this cell against time. So on our dependent variable, we have EMF. On our independent variable, we have time. So this is what happens to the EMF as the time. So we can see that our EMF is decreasing as the time proceeds. So it means as this cell is in operation, we can see that our EMF is decreasing. The time is only increasing. Calculate the value of X on the graph. Remember, this is our initial EMF, and our initial EMF, we calculate it using, so we are having EMF or E theta cell, let me say E theta cell is equals to E theta cathode subtract E theta anode, because we are looking for the EMF at X, which is our initial. I always said we can only calculate EMF initially before the cell starts to operate, where we have potential difference of the two half cell in full. So we know that if you look at the half cell where we're having the water, it is having 1,3223, and the copper is having 0,34. So to calculate the EMF, it means it's going to be 1,23 subtract 0,34, and we are going to get the value of our EMF involved. So the X, don't be confused, because now we are provided a graph. It is just our initial EMF, and it's starting to decrease until it reaches 0 at a time t. Now they say, explain the decrease in the EMF as the time. We know that what makes the EMF to decrease, the EMF decreases as the reactant ions decreases and product ions increases. And then also, and then the rate of reaction, and also when the rate of reaction decreases. So the EMF is decreased by the rate, when the rate of reaction decreases, because the reactant ions are decreasing and the product ions are increases, and then the EMF decreases. What happens to the reaction at T? At T, we can see that at T we have 0 volts. So what does 0 volts mean? We know that 0 volts means that our cell has reached what? Equilibrium. So I like this question because it was asking in a different way. It was asking in a form of a graph, but it was asking exactly what we do every day and what we know every day. Then under electrolytic cell, we will also need to know the energy conversion. We'll also need to know that these are endothermic reaction, and we use energy as the electrical source of the cell. They are non-spontaneous. We also need to define terms like electrolysis and know the processes that occurs in an electrolytic cell. So we know that we are going to look at the decomposition of copper chloride, electrolysis of sodium chloride, electroplating, and refining of copper. So there are only 4 processes that we are going to look at under electrolytic cell. And this is the summary of oxidation and reduction for each cell. Like if you are given decomposition of copper chloride, you know that this must be your oxidation after reaction, and this must be your reduction after reaction. Even if you don't know exactly what is happening, but the oxidation and the reduction after reaction, they will always be the same. You will already know them. When we do refining of copper, this is the oxidation after reaction, where impure copper forming copper ions and copper ions forming pure copper ions. So this is oxidation, and this is reduction summary. And then when you look at electroplating, you know that you'll be electroplating with a certain metal, so that metal will undergo oxidation, and the ions of that metal will undergo reduction and form that metal again. So I'm using X because any metal can be used in terms of electroplating. The last one is the electrolysis of concentrated sodium chloride, whereby we know its oxidation, which is the same as the electrolysis, a decomposition of copper chloride. And its reduction is the reduction whereby we're having water undergoing reduction, which water is going to be reduced to H2, a hydrogen gas. And this is the only one that is a little bit different from the rest that we explained. Now, when you look at this example, The diagram represents apparatus used to electrolysis of concentrated sodium chloride. So immediately when you see this, you can say what is oxidation by the way of this kind of process, what is reduction. And you can immediately go to your notes and say, I know that here is going to be 2Cl minus, giving me Cl2 gas plus what? Plus electrons, 2 electrons. Then reduction is going to be that one of water, 2H2O plus 2 electrons, giving me H2 plus OH minus. So already from this, you can just quickly go to this and remember your reactions. Then what is happening now? You are given a cell and you know that this one is positive, this one represents negative. So we know that this one is the anode side and this one is the cathode side. So this way oxidation occurs, this is where reduction occurs. So they're saying define electrolytic cell. You will define it in terms of energy conversion, where you say convert electrical energy to chemical energy. Write down the half reaction that occurs at B. So at B is our anode side. So we know that according to the summary of the half cell, we're going to have impure copper undergoing oxidation to give you copper 2 plus ion plus 2 electrons. And then write down the name or formula of a gas formed at cathode. At the cathode, there are two gases that will be formed here. In this side, we know that we're going to form chlorine, which is at the this one actually I forgot is B is the it's going to be 2Cl minus, giving us Cl2 plus 2 electrons. So we know that this one is incorrect. I was thinking about the refining of copper. So we know that the gas that is formed here is chlorine gas, and the gas that is formed here according to this reaction is H2 gas, according to this reaction. So we know that the formula of the gas that is formed at the cathode is going to be our H2 gas, hydrogen gas. Referring to the strength of the oxidizing agent, explain why the gas Etna is not Na that is formed. Remember, in this reaction, there was also sodium ion inside the solution. So the reason why sodium is not formed is because H2O is a stronger oxidizing agent than what? Than Na plus ions. Therefore, H2O will be reduced to what? Will be reduced to H2 gas. So the reason why sodium ions didn't undergo reduction is because as we compare water and sodium ion according to that table, if you can look at the side of oxidizing agent, you will see that sodium ions appear at the top and water appears at the bottom of the table, which shows that the strength of the oxidizing ability is more in terms of when we are going down than when we are going up. So that is why sodium ions are weaker oxidizing agents than water. Therefore, sodium ions could not be reduced to sodium, but the water was reduced to hydrogen gas because water is a stronger oxidizing agent. Then, an electrolytic cell of impure copper electrode consists of 95% of copper and pure copper of this chlorine. So they say, is the pure copper an anode or a cathode? Definitely, if you look at this, you know that the impure copper will be at the anode. The anode will have our impure copper. Therefore, our pure copper will form at the cathode. So the correct answer is that pure copper is our cathode. When all the copper in the impure copper electrode has been deposited in the copper electrode, it is found that 6 moles of electrons were transferred. Now calculate the initial mass of impure copper. What is important here is that you need to find the number of moles of the copper that was formed so that you can find the initial number of the initial mass of impure copper. What is important is that when you look at this reaction, is Cu2 plus 2 electrons. Therefore, the reaction of copper is going to be 1:2 in terms of the electrons. So if 6 moles are transferred, it means in terms of the copper, there will be 3 moles that are transferred. So you can find the number of moles, we can find the number of moles of initial copper that is transferred. So we already know that we have 3 moles of copper we want the mass of copper. And how do we find, if we are having 3 moles of copper, we want the mass of copper. You know that N is equals to M over M. Ne? And then this is the copper that was produced. And then it's going to be 3 is equals to M over molar mass. The copper molar mass is 63. Then you cross it, multiply, you find the mass of copper. And then that mass of copper is going to be divided by 0.95, which is the 95% of copper that was found. Remember, it is 95%. 95% is 95 divided by 100, which is going to be 0.95. So we're going to take the mass that we're going to get and divide by 0.95 and find the mass of copper in grams that was initially there. So learners, I know that this was a very rushing session because I was trying to just cover up all the questions that are supposed to be in the exam tomorrow. So after this session, just go back. You can even rewind the YouTube video to check the things that maybe you didn't understand as I was explaining. So we have just come to the end of the session for today. Make sure that you prepare yourself, give yourself enough time of preparation for tomorrow's paper, and make sure that whatever that you have learned today, you go back and revise also in cooperation with the previous videos that we used or that we did for different topics. From my side, I would like to say thank you so much for watching this lesson. Remember to take care of yourself as you are going to write tomorrow. Don't overuse your mind for tomorrow because it might happen that you will have a blackout as you go to the examination room. Thank you so much for watching. Until we meet next time, good luck for tomorrow.